unfortunately, the last talk of this quarter. I think it's been a really fantastic series of speakers, and I'm just really happy to introduce Mike Bostock, who I'm sure many people know is sort of the father of D3, data-directed documents. Mike got his undergraduate degree at Princeton, did graduate work at Stanford with Jeff Hare. I see this as sort of a next generation toolkit, following on some early stuff that Jeff did. And it's just very impressive work. I think it's, my information visualization class, I think all the students doing projects are doing them with D3. And he's going to tell us what makes good software, what makes software good. And it surely has an existence proof of that, because I think I'm very impressed with D3. Also, I think one of the things he's done really wisely is build a set of really powerful examples that help people understand the possibilities of what's going on. And I think examples are really great ways of communicating intent and telling stories about the software. So, Mike, take it from there.
Thank you, Jim, for that introduction and for the invitation to be here. So this is going to be a little bit of a different talk than I normally give, in the sense that I'm really going to be talking about software and the design of software. Of course, it'll be in the domain of visualization, because that's what I do. But it's really what I've been thinking about. I mean, as you know, I work on D3. I created D3. And I write a lot of open source software. And one of the things that implies is, if you write software that people use, is you see people struggling with that software. And so every day I get requests for help. I mean, even writing this talk, I was getting bombarded with requests for help, right? I get emails. I get direct messages on Twitter. I get Slack messages. I get Stack Overflow requests, and then people sending me links to their Stack Overflow requests. I get GitHub issues. I mean, it's like everything. On every channel, I'm getting requests to help. And I love to help people. It's a valuable thing for me to do with my time, because I learn a lot about what they struggle with, and it helps me improve the designs for other people. I help people partly for my own selfish reasons, to learn how to improve my software. But it also is somewhat taxing when you see a lot of people struggling with your software. Fortunately, you see amazing things people do with your software as well, things that you couldn't possibly anticipate that go beyond your imagination. And that's very exciting and encouraging. But it also leads you to wonder, what qualities of software lead people to succeed or fail, right? How can I improve my software to empower more people to succeed? And furthermore, is there a way to sort of articulate your guiding principles? Or is it just the case that you have this intuition that you apply, this internalized knowledge that you're applying on a case-by-case basis? Because even if you think about something a lot, that's a very different activity from articulating it and being able to externalize that. I mean, just ask anybody writing or somebody giving a talk. So ideally, what I could offer you today, and I'm not going to, is something a little bit like Dieter Rams' principles for good design, but tailored for software. And I've tried in the past to give talks that are sort of more about this big picture stuff, things like finding the smallest interesting problem, or identifying and minimizing harmful biases in the tools that you create, or leveraging related technologies and standards. And I think those things are important. The big picture is important. And it's probably more important than the stuff I'm going to talk about today, in a way. But at the same time, I can't help but feel that big picture advice is often impractical or impossible to apply, or even truisms. I mean, it's like saying, make it as simple as possible, but no simpler. Well, duh. I mean, thanks, Einstein. I mean, we all want things to be simpler, but the problem is that we don't know how to get there, right? We don't know what to sacrifice in order to achieve simplicity, right? Because very often there are trade-offs between these different goals. And then furthermore, even if you do get the big picture right, there's no guarantee that your design is going to be successful, or that your tool will be successful, right? The execution of that idea matters as much as the idea itself. and the devil is in the details. So I thought, well, if I can't offer sort of big picture advice, perhaps there's lesser advice that would still be useful. And one inspiration for me is Green and Peter's cognitive dimensions framework, which is a set of discussion tools for raising the level of discourse about the usability of information artifacts, such as code. Now, it's not a perfect framework. No framework is. I mean, it was conceived originally to study visual programming environments, and sometimes it feels like it's a little bit specific to that application, right? Like there's a dimension visibility, which refers to seeing all of the code simultaneously. But in any real software project today, I mean, I can't think of a single example where you can view all of the code at the same time on a single screen. So perhaps a more appropriate dimension might be something like modularity, right? Like the ability to understand completely a small piece of code versus, a large piece of software which has to be understood in its entirety before you can understand any part of it. And the other issue that I have with this framework is that sometimes it's hard to assign usability problems to one dimension or another. So for example, there's hidden dependencies and there's role expressiveness. And both of these seem to imply to me, I thought the code would do one thing and it did something else. So, I mean, I'll talk about them a little bit more, but sometimes it's hard. And even given those limitations, I think this framework is extremely useful. And we need more things like this, and we need to be incorporating this more in our discussions of programming interfaces and of software, so that we understand the cognitive consequences of software design. But I also won't be giving you a general framework today, but I do have some observations I'd like to share. And this is as good a time as any to perform a post hoc rationalization of the last year that I've spent on D3 4.0. I'm not revisiting the big picture design of D3 so much. I'm quite happy with a lot of the concepts like data joins, scales, and layouts. There's still interesting research, of course, but it hasn't been my recent focus. Well, D3 4.0 was initially sort of about breaking up D3 into modules to make it more usable in different applications, to make it easier for other people to extend, and selfishly to make it more fun for me to develop. But in the process, I've also been identifying and fixing a surprising number of quirks and flaws in the API. Stuff that's easily overlooked, but that I believe causes real pain and limits what people can do. I worry sometimes that the changes that I've been making are sort of trivial, especially when they're considered individually. But I hope to convince you that they're not. I worry because I think that we, sort of when I speak of people that write software collectively, tend to undervalue the usability of programming interfaces and instead consider more objective qualities that are easier to measure, like functionality, performance, and correctness. And of course, those things matter, but usability has a real cost, right? Just ask anybody who's struggled to decipher a confusing block of code, or pulled their hair out trying to debug a particular problem, which suggests that we are aware of the cost of usability, but perhaps we don't consider it until it's too late, after we've already committed to something that might have poor usability. And so even if we are aware of usability problems, we need to get better about evaluating usability earlier, and ideally getting better at making more usable software in the first place. I think one of the issues here is that you can't really pick up a piece of code and feel its weight, and its texture in your hands, right? Code is this information artifact rather than a physical or even a graphical one. You can't look at it, you can't see it. Well, you can see text, and you interact with text through your text editor or on the command line. But this is still interaction, right? Of course. And it's subject to the complexities of human factors. And so we should evaluate code like we do any tool, not merely on whether it performs its intended task, but whether it's easy to become proficient and whether using it is efficient and enjoyable, right? So we should consider the affordances of code and even the aesthetics, right? Is it understandable? Is it frustrating? Is it beautiful? So programming interfaces are user interfaces, even though lately it seems like user interface or UI only refers to graphical user interfaces. But to put it another way, programmers are people too. And on the subject of undervaluing the human aspect of design, again, Dieter Rams, indifference towards people and the reality in which they live is actually the one and only cardinal sin in design. And one implication of this statement that I love is that good documentation is not an excuse for bad design, or does not excuse bad design, right? Like, you can ask people to RTFM, but it's folly to assume that they've read everything and memorized it and internalized like all of these arbitrary rules. And so that's one of the reasons why I spend so much time on examples. It's the clarity of examples, and it's the software's decipherability or debuggability in the real world that's likely more important, right? The form must communicate function. Okay, so with that sort of preamble, I'm going to walk through some of the changes that I've been making to D3 with an eye towards usability. But I'm really going to go sort of deep into the weeds of the code here, so I hope this works out. And I'm going to have to start by giving a little bit of background and a crash course on D3's data join. Right, so D3 stands for data-driven documents, and the data refers to the thing that you want to visualize, and the document refers to its visual representation. It's called a document because D3 is based on the standard model for web pages, the document object model, or the DOM. And a simple page might look like this. Like, this happens to be an HTML page with an SVG element. But you don't really need to understand the semantics of every element and attribute in order to get the gist of what the data join does. Instead, just understand that each element here, that's like these little tags here, like this text, is just a discrete graphical mark, right? It's like a letter, or it's a line, or it's a circle. And furthermore, the elements can be grouped hierarchically to make it easier to apply styles to sets of elements or to reposition them. Now, a corresponding data set in this trivial example might look like this. Right? This is just an array of strings, and strings are character sequences, but these strings are just individual letters. But data in D3 can be anything that you can represent in JavaScript, right? And so when we say data-driven documents, what we mean is that we want to take, for each entry in the data array, we want a corresponding element in the document. And the properties of that element should be derived from the corresponding data. And that is why D3 has the data join. The data join is a concise method for transforming a document, taking it from its current state, and adding, removing, or modifying elements so that it corresponds to whatever your new data is. So visually, with a simple Venn diagram here, the data join takes an array of data as input and an array of document elements, and it returns three things, right? The enter selection represents missing elements. That's the new data that is coming onto the page that you may need to create or add. There's the update selection, which represents existing elements, right? Persisting data that you may need to modify. And then lastly, there's the exit selection, which is sort of your leftover elements for outgoing data that you're just going to want to remove or discard. So the important thing here is that the data join doesn't actually modify the document itself. It's not like a completely closed thing. Instead, it just computes these three things for you, and then you can do whatever you want to each of those selections. And that gives you a lot of flexibility and affords expressiveness, right? So for example, you can animate elements when they enter and exit. So in this little animation, the green letters are the enter selection. The white letters are the update selection, and the blue letters are the exit selection. So the enter and exit are sort of staying in the same vertical column, but you'll notice that the white updating elements, they have to shift. So as this is rotating through sort of a different sorted subset of the alphabet. Now, as you can imagine, the data join is sort of used all over the place, right? Anytime you want to create a visualization from scratch, or anytime you want to update it when your data changes, like when new data comes in over the wire or when you're interacting with it, you're probably going to apply the data join. And so the usability of this feature is critical to D3's overall usefulness. So here's what it looks like. I said we were going into the weeds. But I'm going to gloss over a few of the details here, but hopefully I can still sort of convey how you would write this in code. So after joining to data, that's like the first line up here, right? You get your three selections. You get your exit selection, update selection, and enter selection. So for the exit selection, you're just removing those elements. For the update selection, you're updating the horizontal position, the X attribute. That's what's causing them to shift over. And then for the enter selection, you're having to, that's interesting, create those elements initialize them in the right position, and then set the text content of that. Okay, this particular snippet doesn't have the little animation here, but it's not that much of a stretch to go from this version to the animated version that you saw in the previous slide. But already, if you understood that, and I hope that you did, there's still like a slight usability problem with this example, and I've marked it with a hot pepper. And that is that there's duplicate code, right? So you've got this adder x here that you're setting on update, and you've got the same adder x that you're setting on enter, right? And that's because you have your update selection, but they may have moved to a new horizontal position, and then you have your entering elements, and they need to be initialized in the right position. And it's very common that you have to apply, or that you want to apply, the same operations to entering and updating elements, because both of them are going to represent your new data, okay? Now, D3 2.0 introduced a change that was intended to address this duplication. And what it did was, when you appended to the enter selection, it would copy those entering elements into the update selection. Okay? So now you didn't have any duplicate code, because by applying that adder x after appending to the enter selection, this would now refer to both entering and updating elements. Okay? But what that change implies is that you've taken away one usability problem, and you've now inserted a more grave usability problem, right? And that's that there's no indication of what's happening here, right? There's poor role expressiveness when you're appending to the enter selection, right? Most of the time when you call selection.append, it's creating elements, it's appending them to the document, and then it's selecting them. Like, that's what the append method does. It returns the new selection. But here, it's doing that, and it's doing something else. It's modifying the update selection. Secondly, this also now introduces an ordering dependency, right? If you apply this adder x before you append it to the enter selection, it only applies to the entering elements. If you do it after appending to the enter selection, it applies to both. And so that's now a hidden dependency according to the cognitive dimensions framework, because this code, there's no indication that it depends on that order, but now it does. And so it's like we've made a change that's trying to address this common problem. Superficially, it looks like we've made things simpler, but in fact, we've sort of introduced two pretty significant challenges to understanding what this code does. And that ordering dependency is particularly painful because the intent of the data join is to try to make this common operation of transforming the document more declarative, right? It's intended to eliminate sort of intricate logic, branching and iteration that you would have to do if you weren't using D3. And so when you introduce this order dependency, you're sort of letting that complexity creep back in. So the way that this is fixed in D3 4.0 is we've removed the extra magic on enter.append. And in fact, in D3 4.0, the enter selections are exactly the same class as normal selections. There's no distinction between an enter selection and a normal selection. They're exactly the same thing. It's just that one of them happens to be defined by the data join. So to address the code duplication issue, there's now a new method, right, which is selection.merge. So in this case, right after we remove the exiting elements, we append the entering elements, we set their x coordinate. I think I've actually like inverted the two order of operations here. This one should be before and this one should be after. But regardless, the point is that you can take your enter and update, and there's now an explicit method for merging those two things together. And the fact that the method is explicit is really important because there's now an indication of what is happening here, and you're eliminating that order dependency by making it explicit. All right, so what can we learn from this failure? If you look back at the Rams principles, good design makes a product understandable, right? So we failed to do that by having this sort of magic behavior. And again, in cognitive dimension terms, that change had poor consistency because in one context, selection.append behaved one way, and in the enter selection, it behaved a different way. And that's bad for users because it means that you can't extend your understanding or your knowledge of one part of the software to another part of the software. It's even worse than that in the sense of like you're going to assume it behaves a certain way, and there's no indication that it's going to behave differently. right? And that's poor role expressiveness when you're sort of looking at something and there's no indication that it's doing this magic other thing. And as I mentioned already, there's also this hidden dependency in terms of ordering. So by introducing that new selection.merge operator, D3 4.0 avoids overloading meaning, right? We're not silently adding functionality to address this common case. We're instead introducing a new explicit API. So the second example that I want to look at is about transitions. And transitions are a selection-like interface for animating changes to the document. Right? Instead of changing the document instantaneously, transitions change it smoothly over time. Right? They interpolate from the current state to the desired state. One of the things about transitions is they can be heterogeneous. Right? Sometimes you want to apply a transition to multiple selections of elements. So you derive them from a selection, but there may in fact need to be multiple selections that you want to apply the same transition to. Right? So for example, if you have this simple axis here, which consists of like some lines and then text that's showing the value for each tick mark, you want to select the lines and set them to their new position, and you might also want to select the text elements and set them to the new position. And so here's how you might do that, right? You just select the lines, you say I want a transition, and here are the new x1 and x2 attributes, and then you select the text and you define a transition, and then you say here's the new x attribute. And here x refers to some function which is computing the values based on the data that corresponds to each of those ticks, right? So 0.1 or 0.2 or whatever. So it could be a linear scale. Now again, we see some hot peppers here, so there's something bad going on. And there's two things that are sort of wrong with this. One is, again, we have some duplicate code, right? So we've repeated the definition of the transition's duration. So these two transitions are defined independently, and there's no way to say, hey, this other transition is really part of the same thing, and I want it to have the same timing parameters, right? So that's delay and duration and easing. But there's a more subtle problem here, which is that when we declare the second transition, there's no guarantee that it's actually synchronized with the same start time as the first transition. Because when you declare a transition in D33.x, it's just saying the start time is going to be relative to the current time. So these transitions have a delay of 0, so they're going to be starting right now. But the problem is like time continuously advances, including like when you're running code. And so if a small delay occurs between when these two transitions are declared, then they're no longer synchronized. And that might not be visible if it's only a small difference of like a millisecond or two, but in other contexts it might be much more visible, and you might see tearing where elements that are supposed to be together, like a line and a circle that's attached to that line, sort of become detached over the course of the transition. So D3 2.8 introduced a feature to try to synchronize these transitions across multiple selections. And so transition.each was a method, or selection.each is just a method for iterating over each element that you've selected. It calls a function for each selected element. It's just like array.forEach in JavaScript, or like a for loop, but sort of with a more functional flavor. But D3 2.8 introduced, again, some magic to transition.each. And it said, if you are inside a transition.each, and you create a transition, right, if you call selection.transition, it will magically inherit the timing of the surrounding transition. So in this example here, we're creating a transition on the root element. We're setting that duration to be 750 milliseconds. And then simply by putting this code inside of this for each here, any transition that we declare inside there is going to inherit those parameters. Okay, so as we saw with enter.append, this has poor usability because it's changing the behavior of an existing method, right? It's changing selection.each so that it now has this magic, and it's changing selection.transition so that it also has magic to inherit from the surrounding transition. And there's no indication that that magic has been added. So if you understood what selection.each did, there's no way that you would know that transition.each had this new magic behavior. There's also like a funny consequence of this design, which is that if you declared another transition on the same selection, normally that would preempt the earlier transition, but in this case you're just reselecting that existing transition. So that's a fairly uncommon case, but it's also one where the code essentially would just break and really do something that you didn't expect. So the example that I'm using to show you is a little bit contrived. like all of my examples are probably pretty contrived, but it's sort of this balance that you have to take in terms of trying to give you the simplest instantiation of this problem and not like distract you with something that would be like in a more real world example. So there's actually a cleaner way of doing this sort of thing in both older versions of D3 and the new versions of D3. And that is you can declare this root transition or any transition, and then you can subselect elements from that transition. So in this case, I said D3 transition. That's a transition on the document root. And then I'm selecting all the line elements, and I'm doing these changes, and I'm selecting all the text elements and doing these changes. And because I used transition.selectAll, it's automatically inheriting those timing parameters from the parent element down to the child elements. The problem with this approach is, although it's pretty elegant, is that it doesn't work if you already have an existing selection, right? This only works if you're creating a new selection or you're deriving a new selection from an existing transition. So D3 4.0 introduces, or it slightly overloads the selection.transition function. So you can now pass it a transition. And it's similar to what transition.each did in the sense that it inherits those timing parameters from another transition, but now it's something that's being done explicitly, right? It just occurs at this one place, at this one call, where you have selection.transition, where you're passing in the transition that you want to inherit from. And that means that you can now inherit your transition timing parameters from some other selection or from some surrounding selection, whether you have a new selection, as in the case where you're selecting, or whether you have an existing selection that you want to reuse. And this is kind of like a small improvement in the sense of like you could always reselect things before, but it just seemed like unfortunate that you would have to reselect things because it's extra code and there's a slight performance penalty for that. And it's just better if you have an existing transition and you want to be able to derive a transition, or an existing selection and you want to be able to derive a transition from it. Okay, so this maxim is sort of like just an extension of the previous one. We want to avoid overloading meaning, but we also want to avoid modal behavior, which is sort of a more egregious way of overloading meaning. And so what that means is, right, we had selection.transition, but the change in behavior was not like a different class, like the enter selection versus a normal selection. It's simply the context or the time at which you called that method, right? It's calling selection.transition within transition.each. And a somewhat remarkable consequence of this design is that you can even change the behavior of code that you didn't write, right? Like if somebody else has code that calls selection.transition and you call their code within your transition.each, you can secretly change or silently change the behavior of their code. So that's bad. But you know, if you see code that is like setting this global variable and it's then temporarily triggering a global change in behavior, chances are that's a bad design. And so for me, as like the person who brought this onto the world, it's like particularly painful, right? It's like, what was I thinking? And does this mean that I'm a failed designer by like having this like obviously flawed design? But I think there's consolation in understanding why these bad ideas are attractive in the first place, because it means that you can recognize and reject them earlier. And so I think in this case, I was really driven by a desire to minimize perceived complexity, which in my view meant minimizing like new APIs or new methods that I wanted to add in order to support this use case. And I thought I could be clever if I could just sort of reuse an existing API in order to address like this problem of synchronizing transitions. But clearly, as we saw with selection.merge, and as here where we're sort of adding a new parameter to selection.transition, there are many cases where it's simpler to add a new method or it's simpler to add a new interface. And to make the sort of functionality that you want to expose explicit rather than just trying to pattern match to some common case and sort of magically solve that problem for people. So the third example is again about transitions. But it's sort of, well, I'll start with like a very high level description, right? A powerful concept in most programming languages is the ability to define reusable units of code as functions. And by wrapping code in a function, you can call it whenever you want without copying and pasting. And so often you'll see this idea of being able to abstract or encapsulate code sort of repeated, not necessarily in new programming languages, but in software libraries as well, right? They'll have their own abstraction for defining a widget or a component or a chart type or whatever. Whereas in D3, D3 is supposed to be very low level or sort of agnostic or unopinionated. And in D3, if you want to create reusable code, you can just put your code literally in a JavaScript function. And then you can pass that function your selection or your transitions. Now, selections and transitions share many of the same method. And one of the nice properties, or the nice implications of that design, is that you can write a function that is agnostic about whether it takes a selection or a transition. So in this example, I have a function which makes something red. It sets the color style to be red. And if I pass it a selection, it's going to make that red instantaneously. But if I pass it a transition, as we see down here, it's going to do that smoothly over time, right, using the default duration on a transition. However, there's a gotcha to this sort of pattern, which is that the selection API and the transition APIs are not identical. There are certain things that you can only do on selections, like the data join, for instance, or like appending new elements. And so sometimes you do have to write code that is going to be specific. So in D3 2.8, there was another sort of misguided feature, and that was to take D3 transition, and within the context of a transition.each, it would derive a new transition for the given selection, and elsewhere, it would just return the selection that you passed in. Okay, so this will get even more confusing by the end, don't worry. So here you've got your function, right, which is going to make things red. And then you're calling context.each, which is either selection.each for selections or transition.each for transitions. You're then creating a selection which is just the single element, right? So it's going to be repeated for each element you've selected, but you're sort of changing D3's normal declarative style where you're operating on sets of elements and you're now kind of just operating on this one element individually. Okay, and then the next thing, so this is always going to be a selection. But then this one is kind of one or the other. If context is a selection, this is also going to be a selection. And if context is a transition, then this is going to be a transition. Right? So this is a way that you can write code where you have some code that always applies to selections, and then some parts of your code that optionally apply to a transition if you want this change to be applied sort of smoothly over time. Okay, so you probably can tell that this is a fairly poor usability just from my cumbersome description. So we fixed this in D3 4.0, again by introducing a new API, right? We've already removed this transition.each magic, and furthermore, we've introduced a new API for synchronizing transitions. Because one of the things that you need with this design is the ability to, when you create those new transitions, to make sure that they're synchronized with the context transition that's passed into your function. Okay, so D3 4.0 introduces this new transition.selection method, and furthermore, you can then use your normal type checking to distinguish between a selection or a transition, right? So you could say context instance of D3.transition, but in this case, this is called duck typing, where you're just looking for a method that is only defined on transitions, and so that you can distinguish between something that's a selection and something that's a transition. Now, one of the nice things about this, although it's maybe hard to see because this example is so contrived, is that by making these design changes, we can once again write more declarative code, right? Code that applies to the selection in its entirety, rather than code that needs to sort of iterate over each selection and do things on individual elements, rather than sort of applying it to a batch of elements all at once, right? So even though we have to write code in this case that wants to be specific to selections or transitions, it can still be operating on collections of elements all at one go. And in fact, like if you look closely at this example, you'll see that the S selection or the S variable is not used anywhere, and the T variable is just exactly the same as the context that's passed in. So this is contrived, but it's also kind of the point that I want to make, which is that, you know, if you want to write code that is agnostic about whether something is a selection or a transition, you shouldn't sort of have to suddenly change that code if in the future you now want to write some code that is specific to either selections or transitions. Right? So this is what Green and Peter called premature commitment, where you sort of write code one way, and then you would realize like you sort of went down the wrong path, or you got some new requirement, and that would require sort of a dramatic rewrite of your code. So if we can instead sort of think about how do I solve this a different way so that I can continue to write my code the same way regardless of this new requirement that comes up. So another way of thinking about it is that D3 transition method was trying to be clever and do two things at once. So the first thing it was doing is checking whether you're inside this magic transition.each callback. And then if you are, the second thing is deriving a new transition from that selection. But the thing is that that latter part is exactly what selection.transition does. Okay, so this method, d3.transition, was really trying to do too much, right? It was identifying this common case, which may even not be that common. But it was then trying to sort of pattern match and take the things that you kind of wanted to do most often and bake that into this one function that then overloaded the existing function so that it was very confusing. So the maxim that I draw from this is that you really want to think carefully about the operations that you're adding to your interfaces, and that you want to favor parsimony. If there's already one way of doing something, you should try to favor that existing way of doing something. And if you're introducing a new way of doing something, you should try to make that sort of orthogonal from the things that exist already, so that each thing can be sort of separate and used in its appropriate place. Okay, so fourth example is, again, with transitions. So normally transitions are these finite sequences, right? So you're having some set of operations that you're applying over some period of time. So in the simplest case, like each transition is just a single stage, right? So you're taking the current state of the document and then you're interpolating to the desired target state. But there are some cases where you actually want to define sort of more elaborate staged transitions. So this is a donut transition. It comes from a paper by Hare and Robertson called Animated Transitions in Statistical Data Graphics, where they were trying to study whether these types of staged transitions improve perception, right? Is it easier for you to see how the values that correspond to these donut arcs change if you use a staged transition so that you can sort of see individually whether these arcs are getting bigger or smaller? Because the problem with a single stage transition is that the arc is moving to its new position at the same time that it's getting bigger or smaller. Turns out that the answer is no. These stage transitions don't help, and you shouldn't use them, but they look really cool. Okay, so sometimes you may even want to have like infinite sequences of transitions. This is just like a little toy example of some circles that slide back and forth, but it will repeat infinitely if we're willing to wait that long. But D3 has no way of sort of declaring these infinite sequences of transitions, or it has no dedicated way of doing that. However, you can create a transition as part of the end or start event of another transition. And so if you want to do something like this, that's sort of a standard pattern, is you just create the next transition as soon as the previous one ends. So it's not quite as good as being able to declare them all up front. But at least you can sort of do this, even though this is a fairly kind of uncommon case in most visualizations, and it's more sort of like for fun art like this. However, the problem is the recommended pattern is really like the most confusing example I've ever written. And you can see that there are 3 hot peppers here, so it's much worse than the previous examples. And like I'm hesitant to even like try to explain this because I think it probably like exploded your brains already from the earlier examples. But I'm going to try anyway. So first, right, you've got your transition up here, and then you're calling transition.each. It's calling this initialize function. Okay, the initialize function is then creating this circle variable which starts as sort of a selection of just each individual circle. So remember, this is, again, sort of devolved to this iterative thing where we're operating on each element individually. Okay, then you have this ended function, but like what is this? This is a way of defining a self-invoking function, which is kind of a neat JavaScript party trick where you have this function that you're declaring, and then you're immediately calling that function, passing whatever arguments that you want. So in fact, this is a function expression. You can't call the ended function elsewhere. Like, you only just kind of call it immediately right here where it's defined. Now, what that ended function does, again, it runs immediately within the context of this first transition.each, is that it first declares a transition derived from this circle selection. It sets the CX attribute, which is how you move the circle all the way to the right. Then uses transition.transition to schedule another transition when that transition ends. Sets the CX attribute to 0, so it slides all the way back to the left. And then when that one ends, it calls ended again so that it repeats. But here's the extra confusing thing about this, right? So we already have the confusion that comes from transition.each affecting selection.transition, so that you get this kind of magical inheritance of timing. But in this case, it's redefining this circle variable every time that the function, or every time the transition ends. So it'll run right and then left, and then as a side effect of that, it redefines circle, so that every time sort of it needs to add a new link to the chain, it's always adding it to the previous chain. And even more confusing is that the first time this is called, this is a selection, but every other time that it's called, it's now the previous transition. Okay, so yeah, that's pretty confusing. And it's the case where it's so confusing that I wouldn't even remember how to do this, and I wrote the library. I would have to look this up with Google in order to remember how to implement this. And I think that's the best indication that you can imagine of poor usability in your library. So in D3.4.0, we fixed this again by introducing a new feature. And it's a new primitive that didn't exist before. Remember, we've already removed the transition.each magic. And so instead, what we now have is the ability to select the active transition on a given element. Right? So in this case, we're declaring a transition on our circles. And then when the transition starts, we're going to define what that transition does. Okay, that's what this started method does. So we can't declare the whole infinite sequence ahead of time, but we can at least declare sort of this transition lazily, so that when it starts, it goes to the right, then it goes to the left, and then it repeats. Okay, so we didn't need sort of this extra context that applies, or we didn't need to use transition.each and then a self-invoking function that redefined this captured variable. So hopefully this code is a lot clearer as to what it's doing. Right, so this is a case where you have a solution to a particular problem, but it's so obscure and it's so brittle that in practice, it doesn't matter. And I think this is a really important thing, because people will ask you how to do something, and if you feel like you have an answer and you're well, just look at this example and copy and paste that, but that example is impossible for somebody to remember how to use, and is extremely likely that it will sort of be misremembered or misimplemented in a way that it will likely break. It really doesn't matter. Design is all about understanding reality and limitations of reality, the limitations of humans. And so being aware that obscure or very brittle solutions are in practice not likely to solve your problem means that those are not really solutions at all. Okay, so there's another, this is sort of an interesting case where I didn't really anticipate a particular behavior, and the fix is sort of even more interesting. Okay, so if you had one of these transition sequences, or if you had something else where you had sort of an interval that would periodically run these transitions, you could perhaps put your page in a background tab. And then when you came back to the foreground, an interesting thing would happen, and it would do this. And the reason that this would happen is that whatever you were trying to do in the background would be paused, right? Nothing happens. A few things can happen, but generally speaking, nothing happens when your page is in the background. It's one of the ways that browsers save resources. But the problem is when you went back to the foreground, right, you would have this queue essentially that would build up of things that should run, of transitions, right? In the case of that infinitely repeating transition, if you had a transition that you would normally schedule to run on hundreds of elements per second, and you put that tab in the background for a few hours, that could mean you need to run millions of transitions when you bring it back to the foreground. And you'd think you could just sort of like identify those as useless transitions and not run them. But the problem is, according to the abstraction or the design, those are still valid transitions. Like, you're allowed to schedule a transition that has a 0 duration. You're even allowed to schedule something that's sort of in the past and let it run successfully, even if it sort of immediately ends as soon as it starts. And the problem is, when you have this transition chain, like, it never interrupts itself. So you just happen to have millions of transitions that are totally useless, but there's no way for the library to sort of say that those transitions are useless and somehow break the chain. So you need a different solution. And the one that I came up on, this is kind of a joke, but with D3 is to change the definition of time. Right? So transitions don't actually need to be synchronized in the common case with absolute time, like with the wall clock. The intent of transitions is to be a perceptual aid so that you can track objects across views. And what that means is that transitions really only need to operate based on perceived time. And perceived time is only going to advance when the page is in the foreground. And that means that if the page is put in the background, you basically freeze time, and when it comes back to the foreground, it's like nothing happened. The page doesn't know anything. I mean, it's like the spaceman that goes and travels around the black hole and comes back and doesn't realize that thousands of years have passed. It becomes somewhat detached from reality, but it solves this problem by simply changing the definition of time. Okay? So this is a case where when you have certain design problems, it's not always an indication that you need like some new method or you need to change the behavior of an existing method, but you actually need to think about what your assumptions are, like the very basic primitives that those interfaces are built on top of, or the concepts. And in this case, it was just a question of coming up with a better definition of time. All right, so one sort of, I guess I have actually like 2 more quick examples. I think I'm going to go like a little bit of an accelerated rate, so hopefully I can get some questions at the end here. But in this case, so this is another transitions example, but if you want to, so transitions are initiated by events, right? Like you have the new data that arrives, or you have user interaction. But because they're initiated by events, and because they have durations, they're not instantaneous operations, sometimes you can have transitions that are sort of competing to apply to a given element, right? And you don't want to allow those transitions to both run on the same element, because they might try to do 2 things at once and kind of cancel each other out, or do things that don't make sense, right? Like if one is trying to move a circle over to the right, and another one is trying to move it over to the left, then there's no point in allowing both of those to happen at the same time, because it'll just sort of tear apart the page. But the thing is, like, you don't want transitions to be exclusive globally either, right? There are some cases where you want to allow sort of transitions to proceed concurrently as long as they're operating on different elements, right? So this is a case where you're toggling between 2 different types of bar charts. You have a stacked bar chart and you have a grouped bar chart. But the transition is like staggered so that it applies sort of from left to right. So there's no case here where the transition is trying to run on the same, or multiple transitions are trying to run on the same element at the same time, because the delays are carefully sequenced so that they don't compete with each other. But globally, it means that you are running many transitions at the same time. Okay, so given that sort of baseline set of exclusivity, which works in the common case, you still need a primitive to sort of have an out if you need more control over it. And so that was the purpose of the selection.interrupt operator. It was just a way of interrupting the active transition. But there's a slight problem with the selection.interrupt, which is that it didn't also cancel any scheduled transition on that. Okay, so it would interrupt the active transition, but if there were other scheduled transitions, they would continue to run. And the proposed workaround for that was, we'll just schedule another transition with a 0 delay. And that like kind of mostly works, but there's a way around that, which is that if you have a transition which is not active, but it is scheduled, and it has a 0 delay, right? This is a transition that's not yet active, because it won't be active until the next frame. It's still allowed to start, right? Because the way preemption worked in D3 3.x is that that transition runs, and then the next transition starts, and it immediately then interrupts that previous transition. So this is kind of an obscure case, but it's still, kind of a flaw in how the asynchronous API was designed. And part of it was sort of a reflection of some of the limitations of the internals. Like there wasn't an easy way to stop timers inside of D3. They could only basically cancel themselves when they started. But it's much simpler to just change the definition of selection.interrupt so that it not only interrupts the active transition, but also cancels them. And so this is a case where you have to really think through all of those details, right? Like Ram says, you got to be thorough down to the last detail. But that is especially true if you're designing these asynchronous APIs, because the order in which methods are called is highly unpredictable. Okay, so lastly, and I think this is kind of like a lighter weight one, or sort of, you don't have to understand all the internals of transitions and asynchronous programming. But it's still like sort of an important usability aspect. Okay, so changed. This is a D3 3.x, and we're deriving a transition from a selection, and then I'm using like some custom easing here. So I say elastic out, and then I have 1, and I have O.3. Okay, but the problem is like these numbers here are totally meaningless. Like there's no indication of what these values mean. And then secondly, there's no indication like what are the other names that could be used here, and like where are the names defined, and can I pass in my own function, or like how is elastic out defined? Like it's just a black box where we have this string that says what we do. So in D3 4.0, the easing is always just defined by a function. There are some functions that are built in by the D3 ease package, but you can specify your own function if you want, or you can call ease elastic out in some other context if you don't want to use it outside of transitions. And any parameter that you want to specify is now named rather than sort of an additional argument. And that means you can now look it up in the API reference to understand what it does, and there's a helpful image that goes along with it. And so this is kind of a small point, but leads to sort of a bigger conclusion, which is that you want to give hints in your API so that when something is unclear, people know where to look, right? It's not just a number there. There's a word or something that they can refer to, and they can search for it on Google or in your API reference. And I think D3 overall has been pretty good about using named properties, right? It does a lot of method chaining, and then you have these getter setter methods, which all just take one argument or return one value. But you still see it in some cases, and I'm trying to like find those and eliminate those. And I think if you've tried other APIs that have this problem, you'll know like how difficult it is to remember sort of what each of those arguments mean. Like I'm always looking up what canvas context 2d.arc is, because it takes like 6 or 7 arguments that are not named. Okay. So to recap, like we're talking about what the definition is or what qualities make software good. But I want to like recap by saying, well, what's the point of that? Like, why do we want to make good software, right? And it's not just about computing a particular result quickly and correctly. And it's not even just about like concise and elegant notation, right? It's recognizing that humans have powerful but limited cognitive capacity. And many actors compete for that capacity, such as small children. And most importantly, humans learn, right? And so I hope my example showed how the design of programming interfaces has a strong effect on whether humans can understand code, and by extension, whether they can learn how to become proficient. Okay, but learning, I think, goes beyond just proficiency with the given tool, right? It's about what you can take. If you can take knowledge that you've learned in one domain and apply it in another domain, that knowledge is much more valuable. And that's why, for instance, D3 uses the standard document object model and not a specialized representation, right? A specialized representation could, in theory, be more efficient. But the problem is, in the future, if you want to use a different tool, or if you're using something in a different context, any knowledge that you have that is specialized, right, is like specific to that one tool, is not going to be useful. And by extension, the time that you spent learning it is going to be wasted, right? So, you know, you've learned quite a bit about D3 as a side effect of this talk. But I don't really want you to learn D3 for the sake of D3, right? D3 is a means to an end. And I want you to learn how to explore data and how to communicate insights effectively. Like, that's the real point. And so if the software can help you do that, then it is much better than software that just teaches you how to use itself. So I said I wouldn't try to do like a general framework, but I am going to quickly attempt some general principles. Okay? So good software is approachable. It can be understood completely in independent, easy pieces. You don't need to understand everything before you can understand anything. Okay, good software is consistent. It lets you take what you learned about one part and extrapolate it to the rest. It has good guessability. It doesn't self-contradict. It is parsimonious, avoiding superfluous elements. Okay, good software explains itself. It has affordances for learning and for discovery. It is role expressive, and it minimizes hidden magic and hidden dependencies. Good software teaches. It doesn't just automate an existing task, but provides insight or imparts knowledge, such as a best practice or a new perspective on a problem. And then lastly, good software is for humans. It is cognizant of people and the reality in which they live, like Dieter Rams said. It does not expect elaborate and arbitrary rules to be memorized, and it anticipates the need for learning and is tolerant of failure. So, thank you.